On July 1, 1933, Douglas flew an airplane that would never carry a single paying passenger. Only one was ever built. Yet from that lone prototype came a dynasty. It produced 7 aircraft, more than 10,000 DC-3 aircraft alone, a 30% drop in operating costs, and the transformation of commercial aviation from a gamble into a global industry. Each model in the Douglas DC line solved a problem the last one could not. Donald W. Douglas faced a crossroads in early 1933. The airline industry was still reeling from the Depression, and passenger air travel was far from a sure bet. Yet TWA's urgent request for a new kind of aircraft, a fast all-metal airliner capable of crossing the country, sparked a bold response. Douglas and his team designed the DC-1 from the ground up, departing from the wood and fabric conventions of the past. The result was a low-wing monoplane with a streamlined circular fuselage and retractable landing gear, powered by 2 690-horsepower Wright radial engines. On July 1, 1933, the DC-1 lifted off for its first flight, proving that a 12-passenger, all-metal transport could meet the demands of long-range commercial service. But the DC-1 was never meant for mass production. Only one was built, serving as a flying testbed for new aerodynamic and structural ideas. Its true legacy lay in the data it generated and the confidence it gave Douglas engineers. TWA's Jack Fry had demanded a 14,000-pound plane that could fly 1,000 miles at 185 miles per hour, loaded with passengers and mail. The DC-1 met those targets, but Douglas saw an opportunity to go further. He streamlined the design, trimmed weight, and swapped the tri-motor concept for a more efficient twin-engine arrangement. The lessons learned from the DC-1's test flights fed directly into the DC-2, which first flew in May 1934. The DC-2 looked similar to its predecessor, but represented a leap in commercial viability. With a 92-foot wingspan and a lighter, stronger structure, the DC-2 carried 14 passengers at higher speeds and with greater reliability. Airlines quickly recognized its potential. Orders poured in from TWA, United, and KLM. The economics spoke for themselves. The DC-2's operating cost per seat mile was 30% lower than anything else in the sky. For airlines, this meant the chance to schedule more flights, fill more seats, and experiment with new fare classes. For Douglas, it meant the company had moved from building a prototype for a single customer to producing 144 aircraft for a growing global market. The DC-1 proved that a new approach was possible, and the DC-2 proved it could pay. By the end of 1934, the success of the DC-2 had shifted the conversation from whether airlines could survive to how far and how fast they could grow. That shift set the stage for the next breakthrough, one that would soon redefine what an airliner could achieve. On December 17, 1935, the first Douglas DC-3 took to the air. What began as a request from American Airlines for a sleeper version of the DC-2 became the aircraft that would set the standard for global air travel. The DC-3's cabin, stretched to seat 21, offered passengers a level of comfort and reliability that simply did not exist before. Airlines could now schedule coast-to-coast flights that ran through the night, with the Douglas Sleeper Transport DST, outfitted with berths that rivaled Pullman train cars. American's Mercury service let travelers board in New York in the evening and wake up in Los Angeles the next morning for a fare of $185 in a sleeper or $125 in a standard seat. TWA's Sky Chief chased speed instead, shaving hours off the trip and capturing a third of the market in just 2 years. The real breakthrough was economic. For the first time, an airliner could turn a profit carrying passengers alone Earlier models depended on government mail contracts to break even, but the DC-3's operating cost per seat mile dropped to just over a penny. Airlines like United, Pan Am, KLM, and BOAC raced to place orders, and Douglas quickly offered financing packages that made fleet expansion possible even for cash-strapped carriers. The predictable costs and rugged reliability of the DC-3 allowed airlines to standardize their fleets, reduce training and maintenance, and offer more flights to more destinations. By 1939, nearly 90% of the world's airline passengers were flying on DC-3s or their military siblings, the C-47s. The numbers tell the story. 10,355 DC-3s were built, a figure unmatched by any other transport aircraft of its era. The DC-3's range of 1,500 miles and cruise speed of 180 miles per hour pushed the limits of what was possible, shrinking the country and soon the world. Its rugged landing gear and forgiving flight characteristics meant it could operate from rough airfields, opening up routes that had been off-limits to heavier or more fragile planes. For many, the first experience of flight came aboard a DC-3, with its smooth ride, heated cabin, and the promise of arriving at breakfast time on the other side of the continent. The DC-3 did not just change the economics of air travel, it changed expectations. Airlines could now compete on comfort, speed, and schedule, not just price. The model's success forced competitors to catch up, but none matched the DC-3's blend of efficiency and versatility. Even after World War II flooded the market with surplus seawater, the basic DC-3 continued to carry passengers and cargo across every continent. Its legacy is measured not just in numbers, but in the way it made air travel ordinary, reliable, affordable, and available to millions. The DC-3 proved that the future of flight belonged to the passenger, and the world's airlines never looked back. The Douglas DC-4 arrived as the world braced for war, and its design reflected the demands of a new era. With 4 engines and a tricycle landing gear, the DC-4 was built for heavy loads and long flights. Airlines placed early orders, but as conflict spread, the U.S. Army Air Forces commandeered production, transforming the DC-4 into the C-54 Skymaster. Over 2,300 were built, of which 1,219 were for civilian use and 1,121 were for military use. The C-54 ferried troops, cargo, and wounded across oceans and continents, logging millions of miles in every theater of World War II. Its robust wing, high aspect ratio, and spacious, unpressurized cabin made it ideal for strategic transport. And once peace returned, hundreds of surplus airframes found new life with airlines hungry for capacity. The DC-4's sheer numbers and versatility made it the backbone of post-war air travel, connecting cities across the Atlantic and Pacific for the first time with reliable, scheduled service. In the shadow of the DC-4's mass production, the DC-5 stands as an oddity. Only 12 were built, a fraction compared to its siblings. This high-wing, twin-engine design aimed at short-haul routes and rough airfields, featuring a rear-loading door that was decades ahead of its time. The DC-5 could seat up to 26 passengers and offered excellent visibility for pilots, but the timing was all wrong. Production began in 1940, just as the world plunged into war. Most DC-5 aircraft ended up in military service or scattered across distant airlines, never achieving the commercial impact of the mainline DC series. Today, the DC-5 is remembered not for its numbers, but for its daring departure from the Douglas formula, a rare outlier in a family defined by mass adoption and global reach. In the aftermath of global conflict, airlines faced a new challenge: how to make long-distance flight not just possible, but comfortable for the average traveler. The Douglas DC-6, introduced in 1946, answered with a pressurized, oval-shaped fuselage, a leap that allowed passengers to soar above storms and turbulence at 20,000 feet, breathing easily while watching the world slip by far below. For the first time, coast-to-coast journeys could be completed without the headaches of altitude sickness or the constant drone of low-flying engines. The DC-6's spacious cabin, quieter ride, and steady temperature turned air travel into something approaching luxury. Behind the scenes, engineer Harold J. Morrison's insistence on an oval cross-section balanced the need for structural strength with passenger comfort, setting a new standard for the industry. But the pursuit of comfort did not stop at altitude. By 1953, Douglas engineers were locked in negotiation with engine suppliers, searching for a way to push piston technology to its absolute limits. The result was the DC-7, powered by 4 Wright R3350 turbo compound engines, each delivering up to 3,400 horsepower. These engines used a system of 3 power recovery turbines per engine, capturing exhaust energy and converting it into extra thrust, an innovation that squeezed every last drop of performance from the piston era. The DC-7's laminar flow wing stretched 6 feet beyond its predecessor, cut drag, and lifted cruise speeds to 350 miles per hour. Range soared to over 5,000 miles, making true non-stop transcontinental and transatlantic service a reality. The DC-7 could cross the United States without refueling, carrying 100 passengers in a pressurized cabin that felt more like a train car than a noisy, vibrating machine. This was the pinnacle of piston-powered flight, an achievement that would stand only a few short years before the jet age took hold. Today's global airline network owes its shape to engineering risks taken decades ago, risks that made comfort and reach standard, not luxury. As new technologies redefine travel, the legacy of these innovations endures in every boarding pass. Progress in the sky always starts with a leap. Thanks for watching.